All right. So, um, if we're naming now, this structure, um, our naming is gonna start with the branches. Okay, we're gonna name starting by branches. Okay, so that means we have. Do you see if we have two methyl? We can have methyl. That doesn't make any sense. Okay, so in the situation like this, it makes sense to have dimethyl. So, but if you are saying we have two methyl and we indicated by the di, how would we be sure if at which carbon are those metals sitting at? Okay, it would mean that we need to name them, we need to number them. We have 2 and 3. Okay, it's gonna be 2 and 3. Remember, it's 2 and 3. So to separate the two, we have to have a comma in between. Okay, but it's a number to a word, meaning there must be a hyphen in between. Okay, so what is left now is it's a parent name, which is hexane. In this case, hexane, because I have 6 carbon. If we name that here, it's gonna be 2, which represent this branch, 3, which represent this branch. Then, because we're gonna separate a number from a word, then hyphen, because at this point, at this branch, we have methyl, and at this branch, we also have methyl. It makes sense to say dimethyl, dimethyl, dimethyl. Okay, but now we're gonna have a dimethyl hexyl, or you can have a comma, or you can just have hexyl, hexane, yeah, hexane. Okay, so that it's your IUPAC name, or your paid name. Okay, that's what it is. Okay, the question would be, what if what if you were having here chlorine. Okay, or a functional group. Okay, let me do it on this side. That one. The question is now, what if you have a compound like this, or just a straight line compound? Let me not complicate that. Okay, straight line like this, and here you have a branch. Let's say you have a branch, a C. Okay, and let me make them 5. What about, let me make them 5 so that it can make more sense. Okay, let's say here you have chlorine. Okay, so you give preference to an element of halo element, or group 7 element. You give preference to those elements. Then you disregard the rule of starting with a branch. You start with a branch with that element, so you give preference to that one. Okay, so in this case, our counting, if we count number of branches, you can count from here. Okay, it's 1 2 3 4, 1 2 3 4. So this one is out because if we're counting from here, 1 2 3 4 5, 1 2 3 4 5. Okay, but okay, so it's obvious that the name is gonna contain 5 carbon. Okay, we are fine with the parent. We are fine with the parent. Okay, the branches, we are focusing here. 1 2 3 4. Okay, 1 2. Okay, meaning our naming is gonna start from this side going that side, because the closest end of this branch is on the second carbon, but from counting from that side to this side, it's not at the closest, because you have to count up to 4 carbons to reach this one. But from this side, you have to count only up to 2 carbon to reach chlorine. Okay, so you already have that one. Obvious, this one is going to be on the 10th. Even if you have the other one here, let's say you have another C here. Even if you have this one is going to be on the 10th, not on the 4th, because counting from this side, this branch will be on the 4th, but because of this, then this is going to be 10th. It's going to be on the 3rd. Okay, it's gonna be on the. I made a mistake on the first video, but I'll recorrect that one now. Okay. This is your methyl. This is your methyl. This is your chlorine. Okay. How do we name a compound now? Okay. We don't disregard the fact that it has to be alphabetical. Okay, meaning we have to start with this one. What position is chlorine? Second. Okay, so it's gonna be 2-chlorine or chloro or whatever it is, chloride, chloride. Okay, it's gonna be a number again, so tab 3, this. Okay, methyl, it's E here, methyl, then parent name being hexane. So that is a compound name. Okay, that is a compound. Let me quickly go to the mistake that I made here. This is supposed not to be 3, because it's only 3 when you're counting from this side to this side, but we said we have to count from this side. Okay, 1 2 3 4, so this is supposed to be 4, because the branch that is on the closest end of this one, so we have to start from this side of that branch. Okay, it has to be 4. Okay. Let me make another example. The question is, what if you have the very same thing? Okay, you have the very same thing. Okay, it's gonna be H's here, it's gonna be H's here, it's gonna be H's here. Okay, but here you have this, and okay, let's say you have, okay, and let's say you have chlorine here. The question is, where do you start? Because we are comfortable with the fact that you have to start counting the number of the carbon in the chain. In this case, it's pretty obvious that the longest chain would be this chain. Okay, that is pretty obvious. How many C's do we have? Is 6. Okay, we know that we'll have hexane. Okay, the question is, which side do we start with? Where the branch is on the closest end, One would say, okay, this is because it's on the first carbon from this side, the chlorine. We should start from this side. But that is not the principle. Okay? Again, the first preference is given to a functional group. A functional group now is this one. This is a functional group because this is going to be um, alkene. So it's given to a functional group. You start from the side that the functional group is on. Okay, this side is the side with the functional group, or is the side with the functional group, or it's where the functional group is closer. So I have to start from this side. Which oxygen do we then, is the functional group on the first or on the second, or it depends one, but it's preferable to say it's on the second one. Okay, it's preferable to say it's on the second one. Okay, naming this compound now, it requires us to also consider, okay, it's still gonna be there. Okay, consider the fact that we have to start alphabetical order. We need to keep that. This one is gonna be on the sixth one because we're starting from this at 1, 2, 3, 4, 5, 6. Okay, meaning we have to have 6 chloride. Okay, chloride. Okay, 1, 2, 3. Okay, it's on the third. It's on the third. What is it? It's methyl. Then a group name, parent name, hexene. It's no longer hexane. Hexene. Okay, but we need to show about where is the functional group sitting. We're saying it's on the second, so it's gonna be 2, like this. So there is a name. Okay, I think that's it for naming a compound name, given a structure and coming up with accent. A UPEC name. Yeah, that's it. The first, if there is no special element in the compound and there's no functional group, you consider a branch with either methyl or whatever it is, you consider that. But if there is a branch with C, but there's also an element, you start with an element. But if there's also a functional group, or for instance, if here there was an alcohol group, if there was an alcohol group, you will start from here, from the side with an or for instance, if the functional group was here, which is alcohol in this case, it means that the closest end is this side with with reference to a functional group, meaning they will start from this side, meaning this will become 1. Okay, so the first preference is given to a functional group, then a halo group, meaning group 7 element, then you can consider these guys. Okay, you start with the functional group. If there's no functional group, you start with this one. If there's nothing pertaining to halo element, then you consider this guy. Okay, and I think that's it about naming groups and so forth. That's it. All right. As I promised that I will also go into a little bit of giving you an overview on the terminology. Organic chemistry is simply a branch of chemistry that deals with organic molecules. Organic molecules mainly deal with carbon and hydrogen. Okay, hence they say compounds that contain carbon. Okay. This one is not for necessarily for the purpose of this video, but this one is not necessary. Okay. It's also not necessary. Alcohol is represented by this functional group. Okay, hydroxyl group. Okay. Already talked about this one. If the only difference between alkene and alkene is that this has a double bond and this one has a single bond. The only difference between that and this has a triple bond. Okay. These with a double bond and triple bond, they are more reactive. Okay, meaning they are unsaturated. This one with a single bond is saturated. We're still gonna talk about what saturated means. Okay, they are more reactive. Okay, meaning if we're saying they are more reactive, their their boiling point is a little bit higher than this one because they are more reactive because of the double bond and triple bond in between them. Carboxyl group, anything that contain oxygen atom that is double bonded then is as carbonyl group. We have ketone, aldehyde, and also carboxylic group, because on ketone we have a double bond between carbon and oxygen, even on aldehyde. But for aldehyde, the difference between ketone and aldehyde, on ketone the double bond is in the middle. Okay, on the carbon that is on the middle, and then that is it's a ketone. But if it's at the end of the chain, then that is aldehyde. That's the only difference. It's the position. If the position is in the middle of the double bond, then it's ketone. If it's at the end, then it's aldehyde. That's the only difference. Coming here, carboxylic group, acid combined with alcohol. Okay, that is the formula. Okay, because there will be a double bond here between carbon and oxygen, and there will be an alcohol attached to that C. Okay, hence it's like that. Okay, we're still gonna do many questions on this. You don't have to worry about that. If you are reacting, I will also show you this one at a later stage. If you are reacting an alcohol group or compound with carboxylic acid, then you get an ester, and you get an ester. Okay, you've said that as we go along. Saturated, it means that the example is alkane, as I said, is unsaturated. There must be some sort of a double bond in between. Unsaturated would be triple bond or double bond. Yeah, that is unsaturated. Once you hear of the word unsaturated, think of alkene, alkyne, and double bond and triple bond. Think of that. Okay. If two compounds are isomers, it means that they have the same molecular formula. What do we mean by the same molecular formula? They have exactly the same number of carbon and same number of hydrogen, but they have different structures. Okay, those are isomers. So to determine the isomers, meaning you'd have to count how many number of C's do we have here, how number of H do we have here. If they are the same but the structure is different, therefore they are isomers. This question will be a 2 marks question on question 2. Okay, maybe on question 1. We were also there. We already dealt with this part. I don't have to care much. Okay, the boiling point and so forth and so forth. We would deal with those at a later stage. I think this is fine. Okay.